So today we are talking about the second and third derivative of a function. So we can find the derivative of dy dx, which is the first derivative. Dy dx is the first derivative of a function. So we can find the second derivative of a function using this format. D over dx will multiply dy dx. Which will be equal to d2y by dx squared. So this is the second derivative of a function. This is what it looks like, or this is how you represent it, like this. So to find the third derivative of a function, we have to find the derivative of the second derivative of the function, which is this. We have to find the derivative of this. So we will do the same thing, that is d all over dx multiplying d2y by dx square. So this would be equal to d d3y all over d3y by dx cube. So this is the format in which the third derivative of a function is represented. This is the format by which the second derivative of a function is represented, and this is the format by which the third derivative by which the first derivative of a function is represented. So now we are going to look into some examples. So we have a question like this. Give the function given the function y equal to 2x raised to power 5 minus 5x raised to power 4 plus 3x raised to power 2 minus 2x plus 6. Find the first derivative of the function, the second derivative of the function, and the third derivative of the function. So what we know is that the first derivative of the function is represented like this, dy dx. And the second derivative of a function is represented by the 2y all over dx square, all over dx square. And that the third derivative of a function is represented using the 3y by d3 cube square. This is square cube. So now let us look into some examples here. So to find the first derivative of the function, what we have to do here now is 2x raised to power 5. 5. So to find the derivative of a function, this is what we do. It's usually in this format. So therefore, dy dx is equal to a multiplied by n square x raised to power n minus 1. So to find dy dx of this single function here, or this monomial, what we'll do is 5 multiplied by 2, which is 10, 10x. Now 5 minus 1 is 4, minus 4 multiplied by 5 is 20, x. 4 minus 1 is 3, plus 3x. 3 multiplied by 2 is 6, x. 2 minus 1 is 1, but we don't have to represent that here. Now this is 2x. As you know, this is 2x raised to power 1. Okay, so 1 multiplied by 2 is 2, x. 1 minus 1 is 0, and we know that whenever a number is raised to 0, it becomes 1. Okay, so what this means is that the derivative of 2x is 2 only. Okay, the derivative of 5x is 5 only. Okay, is 5 only. When you are asked to find the derivative, that's the y dx, it is 5 only. 6x is 6, 7x is 7 only. So now coming to the last step, whenever a number doesn't have a letter attached to it, or a term attached to it, what you have to do now is just this is equal to 0 plus 0, but we don't have to represent that here because it's 0. So whenever you add 0 to anything, it's still that same thing. So when you're asked to find the derivative or of a function without a letter attached to it, or just a number without something attached to it, then it's going to be 0. Now finding the second, yes, and this is dy dx equal to this. Dy dx So to find the second derivative of the function now, which is represented by the 2y all over the x square would be equal to, now we have to find the derivative of this function. So 4 multiplied 4 will multiply 10, which will give us 40, x. 4 minus 1 is 3, minus 20 multiplied by 3 is 60. 3 minus 1 is 2 plus 6x would just be 6 minus 0. So we don't have to attach the 0 to it. So to find the third derivative of the function, it will be represented in this format: the 3y all over the x cube equal to 3 multiplied by 40 is 120. 3 minus 1 is 2 minus 2 multiplied by 60 is 120. 2 minus 1 is 1. So we don't have to present that. And we know that this is 0. So this is the first derivative of this function. So for the function 2x raised to power 5 minus 5x raised to power 4 plus 3x raised to power 2 minus 2x plus 6, the first derivative of this function is 10x raised to power 4 minus 20x raised to power 3 plus 6x minus 2. And the second derivative of the function is given by the 2y all over the x cube is equal to 40x raised to power 3 minus 60x raised to power 2 plus 6. And the third derivative of this function, which is given by the 3y by or all over the x cube, is given by 120x squared minus 120x.